As war clouds gathered over Europe and tensions in the Pacific were rising, almost everyone was rearming in one way or another. But a less appreciated aspect of this endeavour is often the logistics. The US Maritime Commission had recently been formed with a general intention of revitalising the increasingly obsolete US merchant marine. But one of the areas that drew specific attention was that of oil supply. As pointed out in a US Navy Institute Proceedings article in 1938, the US Navy had approached World War I with a single lonely oil tanker to support it. And given that any war would involve sailing a long way with a fleet that was now entirely dependent on oil, and with the additional demand of substantial amounts of aviation fuel, quite apart from the fact that newer, larger ships demanded a larger volume of fuel generally, it was clear that the US Navy would need a large logistics train of oil tankers available if it wanted to actually go anywhere. But oil tanker design was a somewhat scattershot thing in the 1930s. Various companies designed their own ships for their own purposes, and thus size, range, carrying capacity and the like could vary considerably from company to company, and even within a single company, as some of their ships would be built for coastal trade, others for deeper ocean trade, some would be built either with river work largely in mind or almost entirely in mind. Some were designed for deep oceanic work but only at short distances, such as hops across the Caribbean, while others would be designed to withstand almost round-the-world voyages. But one near constant in all of these ships was a relatively low speed, since a slow ship used less fuel, needed a smaller amount of space for the machinery, a smaller engineering crew, and various other factors, all of which added up to cost savings that were very useful if you were running oil commercially. But the US Navy needed ships that could either keep up with the fleet at cruising speed, or at the very least get to and from bases and fleets in a reasonable time. And so the Maritime Commission set about a two-pronged approach. It would mandate a series of standardised designs which would greatly simplify logistics as and when these ships were taken up into naval service, and it would also require somewhat greater speed than a brisk jog, with certain subsidies being made available to cover some of the costs for the commercial operators who, it was envisaged, would be building and operating most of these ships in peacetime. Eventually, three categories of oil tanker were devised. The T3 type was the largest and fastest, with the Cimarron class being a famous example. But only a few dozen of these fleet oilers were ever built. The T1 was the smallest, seagoing, but mostly intended for coastal work, and also, ironically enough, being the last standard type to be agreed on. And that meant that the bulk of fuel hauling, both behind and to the front lines, would fall on the sometimes unheard of T2 class. Like most tankers of the time, these ships had their machinery spaces right aft to simplify oil tank distribution, but the superstructure remained amidships to assist with ship handling and navigation, which made the tankers have rather unique profiles, which made them distinct targets for raiders in war, both of the above and below surface variety. Compared to the T3s, the T2s were relatively close in capabilities, but being just a little less ambitious, they could be built in far more places and in far greater numbers. Displacing around 21,500 to 22,000 tons fully loaded, the first T2 design called for a 12,000 shaft horsepower turbine plant driving a single screw for a top speed of around 60 knots when fully loaded, with just over 141,000 barrels of oil, which is equivalent to just under 6 million gallons. Another couple of knots of speed was possible if they were unloaded. No less than 7 sub-variants of this, including the original T2 design, would then be built over the next few years. Some were a little bit larger, but the biggest variation was power output, with various engines fitted, which would result in a variety of top speeds. The most common version was the T2 SEA1, which was a little bit larger than a baseline T2, but only had a 7,200 shaft horsepower turbo-electric drive, and thus could only make around 15 knots at a push. This was designed to reduce demand for gear sets for turbine engines, which would allow the limited supplies of these gearing sets to then be redirected to warship construction. Well over 500 T2s of various specs, with around 90% of them being the T2 SEA-1 type, were built. This vast fleet meant that early losses in Allied tankers to the U-boat assault, which had initially seemed to have the potential to sever vital fuel supply lifelines, were considerably more than made good. As with the more general-purpose Liberty ships, the T2s were built in near record times, with the construction of some ships taking only around a month from keel to launch. But, like the Liberty ships, this rapid construction, using many recently trained workers and the extensive use of both welding and, let's just say, secondary quality steel, did lead to some issues, including a number of ships which just flat out broke in half, usually in poor weather, although the SS Schenectady, as well as being near unpronounceable, also managed to snap in two, completely apropos of nothing, while sitting in a calm-fitting outberth, and thus drawing considerably more attention than some of the other losses. These issues would later be somewhat addressed by the installation of a pair of riveted steel straps to the hull. Post-war, some were kept in naval service, while many were released back into commercial service, where they'd go on to see very active lives, a larger number having an entirely new midship section installed to both expand their oil capacity and renew their systems at the cost of about 1/3 of that which would be needed to build a brand new ship. And although many would be scrapped in the 60s and 70s as they were surpassed by newer, larger tankers, a few would remain in reserve in the naval sense, or in commercial service generally, until the 21st century, with the last few apparently going to the breakers as late as the early 2010s.
That's it for this video. Thanks for watching. If you have a comment or suggestion for a ship to review, let us know in the comments below. Don't forget to comment on the pinned post for dry dock questions.